Welcome back to another episode of Illuminating Information, the podcast where we shine a light on the cutting-edge ideas shaping the way we work and innovate. Today, we're continuing our conversation with our CTO, Jakob Praher, about agentic AI. In part one of our conversation, we unpacked what agentic AI is and how it differs from generative AI. Now, if you haven't checked out part one, I highly encourage you to do so before listening further. Now, on today's episode, we'll be digging deeper into how large language models play a major role in this space and how our groundbreaking solution, Mindbreeze InSpire, is empowering teams with deeper insights and smarter collaboration. Now, back to the conversation. Now, I want to pivot the conversation a little bit here. At the beginning, we were talking a lot about large language models and the power of those large language models. Just for the audience and for the listeners of the podcast, can you break down how large language models complement agentic AI and what unique capabilities do they bring to the table?
Yeah, so the agentic AI predates, of course, the current AI boom. So the concept of an agent is a very foundational element in artificial intelligence, because in the end, artificial intelligence also means that one can act in an environment and solve a goal, for instance. So like a good example for agentic AI is a self-driving car, which basically has to, of course, act and drive. When it drives from one point to another point, it has to observe other participants in traffic. It has to understand weather situations, all kinds of things. And always there is acting, like steering or braking or accelerating and so forth. So all these kinds of things are actions that it takes such a machine in the environment in order to drive a car from one place to the other. So it's a good example of an agentic AI, which does not directly mean that, for instance, self-driving cars need large language models, but of course one can also use these large language models with such self-driving cars in order to better understand the environment. But especially with these large language models, it became popular to interact, to chat with such models. Because if they are trained for what one calls instruction trained, so when they are trained for chatting, they are human-like. So they basically not just generate text just in order to continue the text. That's one use case for generative AI, but the other is that basically that it responds with an answer to a question, which is not just continuing the question, but to really respond. And this kind of understanding and human-like behavior can also be used in this agentic AI, basically also to reason about. So one can, for instance, also train these models to be good at reasoning. So basically to try to understand the task which they have to solve, to break it down into subtasks, and then to use tools, to use other things, because of course not everything can be trained into these models. So there are facts that are, or something that has to be computed. So for instance, if you want to solve a mathematical computation problem, you cannot just learn all of this and map all this to the model, but you have to then execute the program that does that. But the model can, of course, generate the program that can solve this and then execute it. And this task of taking tools which can, for instance, solve things that they cannot solve for themselves because it's not in their model, is actually the interesting element of this agentic AI. So you need typically for these modern agentic AI solutions, you need, of course, a large language model in order to interact with these tools. And then this large language model, or a set of such large language models, can then be used in order to use tools and also in order to evaluate how far they are already at solving the problem or the task at hand. So basically what agentic AI is, you have a task, you break it down, you use tools, and for all of this interaction, of course, you need to have this large language model in order to have the reasoning power, to have the semantic understanding to do the next step, and then you assemble this in a way that solves a larger task. And therefore, in those modern agentic AI solutions, the large language model is basically a key element. Also, Gen AI is basically part of it, because of course if it wants to call a tool, it of course generates the expression to call the tool. So it has to do this, but the way it is not just a simple step, so basically giving it a prompt and then it generates things, but to use this in a setting, in a setup, and to use potentially multiple such LLMs, or to use different ways how to interact and so forth, so to ensemble it. And then you have basically a system that can really solve more complex things.
Last question for you here, Jakob. Just kind of building off of what you talked about there, the large language models complementing agentic AI, kind of bringing it back to the Mindbreeze lens, what are the challenges of integrating LLMs into enterprise tools like Mindbreeze InSpire, and how are those challenges addressed?
That's a very good question. So from our side, we are not newcomers in machine learning. So basically, when we started Mindbreeze, we always had the task to understand those vast data landscapes of our customers. And so machine learning and data-driven technologies were always in our focus and were always our daily bread. So basically, InSpire itself, in the indexing, it's data-driven. So it really gets interesting when you apply InSpire to a lot of large data sets. And therefore, also, for instance, the semantic search in Mindbreeze, this is also based on machine learned models, or also extracting entities or classification or topic modeling. All these kinds of things are, of course, data-driven technologies. So we always had, of course, the natural issue that we had to provide tools for measuring the quality of our systems, also relevancy. If you want, for instance, in search, it's also a semantic issue, because you want to provide the user with the relevant information. What does relevant mean? It can be broken down into the terms or core, where some boostings are, where that the user often clicked on, and so forth. As you see, you cannot write a unit test in a programming language and then the relevance is solved. You need to provide tools for measuring how relevant the answers that Mindbreeze, for instance, answers are, and therefore we always already had such tools in place to test. So we had query testing, relevance testing systems, like you have a data set, you can evaluate this data set, you can ask the queries, and then you can measure. And then if you tune Mindbreeze, you see that the tuning is effective. So the efficiency of testing and tuning. And this is also the same thing for these large language models, but you have other issues. So it's much better understands semantics, and you have less work in data preparation, because you can just give the model the text and it already, if it's properly trained and works good, it will have a good answer, but it could be that this answer is wrong, and it's not factful. And in more complex use cases, it falls apart, and therefore you also need tools. You need these tools. We call this the evaluation framework. The evaluation framework is basically, it combines the solutions with the ability to measure the quality of the solutions by using data. So data is basically the only way, labeled data in this sense, to say, okay, I have, for instance, a data set which I already provide the answers with, and then you can say, okay, what do I expect? And then you can measure it. Of course, the more advanced these models are, the more complex it is to compare the output against some metric, so like correctness. So if the model summarizes something or generates an answer from a complex task, it's not so easy because you again need semantic understanding. You cannot just compare the things together and then you say this is the same, yeah? Because what does mean the same? The same can then also mean semantically the same, yeah? It can be written in a different form, but still it is correct. So it's not just like easy comparison, but then you can use again models like LLMs to provide these metrics, yeah, with a separate tool, and then basically to measure the quality. The most important thing is also always that the human can be in the loop and can give feedback as well, because sometimes it's really also important that one works through these things, but these evaluations then give you an engineering approach. Yeah? An engineering approach means you can measure progress. Yeah? It's not just you measure the current state and then you can also measure the progress. So if I change something, do I make it better or do I make it worse? So the direction, yeah? So that you can work towards optimizing things. Yeah? So, and this is really in our DNA because we worked from the beginning of Mindbreeze with data. And I think this is also what gives us an advantage here and what gives our customers an advantage, because we know this, we went through all this, it's not new for us. Yeah?
Awesome. Well, that wraps up another enlightening episode of Illuminating Information. Before we head out, any closing thoughts for the audience, Jakob?
First of all, thank you very much for inviting me, and I think this is really a fascinating time we are in. I mean, so I think what we can learn also from all these techniques and about us, it's really also very fascinating. So I think one should not forget how fascinating these developments are and how, if applied in a good way, how that can really positively improve our life. So I think that's really something that sometimes one forgets, or also I forget about when one is too much entangled into the details. So I really like to step back and also listen to great voices and people that reflect about these technologies to give it also perspective. It's really fascinating how much we can learn, and I think this learning and this openness, I think this is a very important part, which I cannot stress enough. Yeah, so that's really what I want to say.
Awesome. Well, I appreciate all of your insight, and especially the level of technical knowledge that you have. I think was really enlightening for the viewers. Huge thank you again, Jakob, for sharing your expertise and giving us a behind-the-scenes look at the incredible potential of agentic AI and the role Mindbreeze InSpire plays in driving smarter, faster, and more connected teams. Now, to the viewers, if you found today's conversation insightful, be sure to subscribe to Illuminating Information on your preferred listening platform so you never miss an episode. And don't forget to share it with your network. There's always someone who could benefit from the latest in AI innovation. Have a question or topic you'd like us to cover in future episodes? Know someone who might be a good guest on our show? Reach out to us on our website and let us know. Stay curious, stay adaptive, and as always, keep illuminating information.